Okay, so now we're on single number 1, where the assignment is to talk about the 6 different reactions and balancing them. So the first one I have here is C plus H plus O2, and the products are CO2 plus H2O. Now, this reaction is a combustion reaction, and the reason is because whenever you have hold on, whenever you have carbon and hydrogen reacting with oxygen, you're gonna get carbon dioxide and water. So this uh, the products here are carbon dioxide and water, so it's a combustion. So now we're gonna balance it. So first we have C, H, and O. So now we have one C, one H, 2 O's. And now on the product side we have 3 O's. Sorry, I almost put 2. 3 O's, 2 H, 1 C. Now you look at this and you're like, all right, the carbon is balanced. Ooh, the hydrogen is unbalanced. So we want to change that. So simple. So what we're gonna do here, since you have H2O on the product side, we're gonna change that. We're gonna change the H2O just because it has O in it. So we're gonna change that to 2. So now it's gonna change it to a 4. Change the oxygen to a 4. Now we're gonna change the hydrogen on the. Oh, sorry, that's really sloppy. We're gonna change the hydrogen to a 4. Yeah, I'm sorry, that looks really bad and you can't really see it. Sorry. All right. Yeah. So we have 4 hydrogens on each side. So now we're gonna change the O2 on the reactant side. We're gonna put a coefficient of 2, so it equals out to a 4. And boom goes the dynamite. You have a combustion reaction that is balanced. Hopefully, a huge fireball won't happen. So now, the second type, we're gonna go with a synthesis reaction. So the one I have here is Na, Na, sorry, you can't see that, plus Cl. Can you see that? Yes, you can. Na plus Cl2, and it gives NaCl. Now, the reason this is a synthesis reaction is because, the normal, let's say, algebraic formula for it would be A plus B equals C. So two elements combine to create one two reactants combine to create one product. And now we have Na plus Cl, and that is, and it reacts to form NaCl. And so, what we're going to do here, we're just going to do, just like every single reaction, we're going to list both, elements, NaCl, and now on the, sorry I'm stuttering here. I'm trying to do this in one take, so it's completely unfiltered and unrehearsed for you, Miss Simmons. So it's natural as possible. I mean, not organic, that's the word, organic. So now we have one Na and 2 Cls. And on the product side, we have one Na and 1 Cl. So when we look at this, this is pretty simple. All we have to do is put a 2 on the product side, change the Na to a 2, change the Cl to a 2. Now Cl is balanced out, so all we got to do is put 2 in front of the Na, and yeah, there you go. There's your balanced equation right there, your balanced synthesis equation. So now, the third one we're going to do is a decomposition reaction. So, for this one, I'm going to put, for this one, it's going to be, oh, sorry, I don't know why I put an A there. H2O2, and it reacts to form H2O plus O2. Now, a decomposition reaction is when it's like one product with, like, say 2 or 3 reactants. The product, it sort of splits apart and creates like individual elements / reactants. So as you can see, we have H2O2 here, and it splits to create H2O and O2. So you see it sort of splits apart. So now to balance it, we're gonna go with H and O right here. So now we're gonna put a 2 in front of the H and a 2 in front of the O. And now on the reactants, on the product side, we're going to go with a 2 on H and a 3 on the O. So right here you realize, oh, okay, it's what's it called? The O isn't balanced. So what we're going to do is we're going to change the O2 right here, the H2O, the nice water. We're going to change that to, we're going to put a nice 2 right in front of it. So now it's going to change the oxygen to a 4 and the hydrogen to a 4. And now, simply put, you're going to see H2 and O2, and you're going to put a right big fat 2 in front of it. It's going to change the H to a 4 and the O to a 4. Now, as you can see, our decomposition reaction is now balanced. Now, what we have now, what we're going to do is a single displacement reaction. And so what we're going to, first we're going to write out the equation that I want to do, which is mg, I'm going to zoom in, so my fat fingers can't do that, mg plus HCl, and it reacts to form H2 plus MgCl2. Okay, so now, this is a single displacement reaction. And now the reason is because one H over here in the reactant side has been, say, kicked out of that compound, has been left alone out to dry, and Cl is now taking Mg in because, people change. And so, the normal, let's say, equation would be A plus BC reacts to form B plus AC. So now you see H is our B, and that breaks up with the Cl, and it wants to be left alone. So now, what you're going to see here is we have Mg, H, and Cl. Now, we're going to put a 1 in front of the Mg, a 1 in front of the H, and 1 in front of the Cl. Now, for the H2, ooh, so simple, so nice. For the H, we're going to put a 2, 1 in front of the Mg, and a 2 from the Cl. So now, easy, you can see that H and the Cl are balanced. You see that in the reactant side, all you got to do is just put a simple, nice little 2 in front of it, and that's going to change it. All right. sorry I'm a little, sorry if I sound a little nasal. I know it's not really pleasurable to hear, but yeah. Alright, so that is our single displacement reaction, and that is number 4 of our 6. And now we're gonna go on to number 5, which will be our double displacement reaction. And I'm so sorry if like the angle, if you can't really see what I'm doing at some points, because I have my phone propped up and I'm trying to get a nice angle, and I have my iPad against a chair. Like if I go against the chair, there's like a shadow in front of it, then you won't be able to see it at all. So I'm really sorry if it's not that, if you can't see it for a few seconds, but I'm at least saying it so you can hear what I'm doing. All right, so we're gonna do our double displacement reaction, and that will be HCl plus AgNO2, and then that reacts to get the product of AgCl plus HNO2. Ooh, that's a little slanted, but we can live with that. Okay, so now this is a double displacement reaction because you can see that 2 of the elements have switched sides. You see the Ag and the H. See, they were like, I want to break up with. They were both like, I want to break up with you two and go with the other one's girlfriends, because they're weird like that. And so the normal equation would be AB plus CD reacts to get the product CB plus AD. So you can see our A is the H and our C is the AG. So you can see both of them have been switched around. So now we're gonna list all of our reactants and our products. HCl, Ag, and then O. Not NO, because NO are individual elements just smushed up in a compound. So you gotta separate those. Alright, so now we have 1 H, 1 Cl, 1 Ag, 1 N, and 2 O's. And now we're gonna have 1 H, 1 Cl, 1 Ag, 1 N, and 2 O's. Oh, and now you can see that this equation is already balanced, and it all works out because now H and the Ag are happy with their new companions. So there's nothing feisty going on. So yeah, that's our double displacement reaction. And now we're gonna go to our 6th and last one, which is the acid-base reaction. So now what I'm going to do is this. Our equation will be I'm gonna zoom in there. HNO3 plus NaOH, and that reacts to get the product NaNO3 plus H2O. Okay, so now this is an acid-base reaction because when you combine an acid and a base, you're most likely going to get water. And so our base here is Na, and our acid is NO, and they have reacted to form a base and a acid plus the water. And so our normal acid-base reaction equation would be HA, the A meaning the acid, plus BOH, B meaning the base, O meaning oxygen, and H meaning hydrogen. And that would all react to form the product BA, which is base acid, plus H2O, which is water. Okay, so now we're gonna list all of our elements: H, N, O, N, A. Oh, yeah, that's it. So now H, we have 1. N, we have 1. O, we have 4. Oh, sorry. H, we don't have 1. H, we have 2. Sorry about that. And Na, we have 1. Now for the products, we have Na, which is 1, oxygen, which is 4, N, which is 1, and golly, we got ourselves 2 hydrogens. So you can see all of them, it's already balanced. And you would just balance this just like any other equation, split up all the elements individually, write what's in the reactant and product side, and, balance them by, putting coefficients in. So no biggie there. And now I just want to reiterate that this is a acid-base reaction with NO being the acid and Na being the base to create the product of a base and an acid and water. So, Miss Simmons, that is the 6 reactions. And yeah, I hope this video wasn't too irritable with my nasal voice. So yeah.